Okay, so today we're going to talk about projectile motion, and effectively projectile motion is motion that is in both the x and the y direction. And a key idea about projectile motion is that the x and y motion are independent of each other. So essentially, the accelerations are only affecting, like if you have a y acceleration, it's only affecting the y directions, and if you have a x acceleration, it's only affecting the x acceleration. And so, talking about the idea of acceleration, the only acceleration you have vertically is gravity. So gravity is the vertical acceleration. So AY is 0, and that's what we, AY is 9.8, negative 9.8 meters per second squared. That's right, it looks a little messy there, huh? And that's what we looked at in the last chapter, that gravity was negative 9.8. And for our purposes in this chapter, we are not going to have a horizontal acceleration. We're going to say something is being just thrown out there, it's just moving freely in space, and there's nothing that's propelling it. It's not a rocket or anything like that. So it's just moving on its own, and so there is no x acceleration. So there's no horizontal acceleration. And we are assuming the absence of frictions. There's no air resistance, there's no horizontal friction. So AX equals 0. Okay? So the only acceleration you have is a vertical acceleration, and from this statement here, we're saying that the vertical acceleration is going to only affect the vertical velocity. So kind of what that looks like in terms of looking at how an object moves. Let's say that I have a ball and I throw it up, and I conveniently throw it up such that it has an x velocity of, let's just say 10 meters per second, and a y velocity of 19.6 meters per second. Okay? The only acceleration they have is the y. So AY is negative 9.8 meters per second squared, AX is 0. So if I were to look at these intervals, and we're going to assume these are 1 second intervals, 1 second later, my horizontal acceleration of 0 has not affected my horizontal velocity. So my horizontal velocity is still 10 meters per second. My vertical velocity, though, has been affected by gravity. My vertical velocity is going to change by negative 9.8 meters per second. So I started with 19.6, I changed by negative 9.8, so now my velocity is 9.8. Conveniently. 1 second later. Again, I don't have a horizontal acceleration, so my x velocity hasn't changed. My y velocity, though, is going to change by negative 9.8 meters per second. So I'm going to go from 9.8 meters per second. With that change, I'm going to have a y velocity of 0 here at the top. And we saw that in the last chapter. When you throw an object upwards, the very peak, its y velocity is 0. The same is going to be true if it's a projectile. Even though it's moving in the other direction, the y velocity is 0. It has an x velocity, but the y velocity goes to 0. 1 second later, again, my x velocity is still going to be 10 meters per second because that's unaffected. My y velocity is going to change by negative 9.8. So here I'm at 0, so here I'm going to be at negative 9.8. And then you could see, well, okay, at this second, I'm still going to have a y of 10, or an x rather, of 10 meters per second. And I kind of run out of room for my y, but my y would be negative 19.6 meters per second. And again, this should look familiar. The symmetry is similar to when we talked about just a vertical motion going up and down. So key idea, huge, big idea is that horizontal motion and vertical motion are completely independent of each other. So because they're completely independent of each other, then the equations are going to be independent of each other too. So let's look at the kinematic equations that we had from the previous chapter. So in the previous chapter, here were our kinematic equations. Okay, again, these should look familiar. All I've done is kind of gone subscript crazy with these. But before you write them down, just kind of looking at these, let's see what happens with the knowledge that we have a zero value of acceleration for the horizontal. So I'm saying my AX is 0. Okay, AX is 0. So if AX is 0, then this whole term is going to become 0. And if that whole term becomes 0, then this is going to go away, and that just tells me that my x velocity is equal to my x velocity, and that's nothing new, so that's just going to go away. The second equation says that this is 0, so the whole term is going to become 0, and that means this whole side will go away, and I'm left with delta x is equal to bx naught times t. Well, that is pretty straightforward. That's our distance equal to our rate times our time. And then our last equation, again, if acceleration in the x direction is 0, this becomes 0, and this whole term goes away, which means that my x velocity squared is equal to my x velocity squared, and again, that's nothing new. So essentially, our x equations really do simplify, and this is the only x equation you have for a projectile motion. So this is the one we should write down for horizontal. For vertical, though, it doesn't simplify. Your y velocity is equal to vy naught plus ayt. You still have an ay in all of these, so you're still going to have the same set of equations that we saw in the previous chapter. We're just going to be in particular saying that these are y values. Okay. So for projectile motion, you effectively have 4 equations to kind of work with, but they're familiar equations, so we should be okay with that. What we're going to do now is we're going to focus in on one particular type of projectile motion, and that is called the horizontal projectile. So for horizontal projectiles, effectively, this is saying you have an object is projected with only an initial x velocity. So that means that vy naught is going to equal 0. And so that will end up simplifying our equations quite a bit for these types of problems. So effectively, you've got something that's like being shot off the table, a cliff, etc. Okay, so it only has right here vx naught. And then the moment it begins to fall, well, then we start to have a y velocity because gravity is acting on it. So we will look at some problems doing this in class.